Every single time you stream a video or send an email or just scroll through your feed, you're tapping into this massive, invisible network of data centers all over the world. But here's the thing. That digital world has a hidden cost, a huge energy bill. So what if we could make the cloud smarter? Today, we're diving into a brand new AI approach that's tackling this problem head-on, and it might just be the key to a much greener digital future.
So that really begs the question, right? Just how much power does it take to run our digital lives? The scale is frankly staggering. And as our hunger for data just keeps growing, so does the environmental footprint of the tech we use every single day.
Okay, so let's get right into the heart of the issue, the internet's energy problem. We're going to take a look at what's really powering the cloud and why it's become such a massive challenge.
To make these giant facilities sustainable, we can't just keep throwing more power at them. The real solution isn't about generating more energy, it's about using the energy we have way more intelligently. We need to make these data centers smarter.
And that brings us to something I'm calling the Great Virtual Shuffle. You can think of it like a high-stakes digital game of Tetris. The goal is to pack everything in as tightly and efficiently as possible to save energy, but you have to do it while the game is running at full speed.
The key technique they use to do this is called live migration. Now imagine trying to rearrange all the shelves in a packed warehouse during peak shopping hours and doing it so perfectly that not a single customer even notices. That's basically what this is. It's moving a running virtual machine from one physical server to another with absolutely zero interruption.
But here's the catch. For years, engineers were stuck in what's called the migration dilemma. You had two main options. You could use Precopy, which is slow and steady. It copies data in the background with almost no disruption. Or you could go with Postcopy, which is super fast, but it means you have to shut down the service for a little bit. So you were stuck with this trade-off, be slow and safe, or be fast and disruptive. There was really no good middle ground.
But what if you didn't have to choose? What if you could actually get the best of both worlds? Well, this is where a brilliant new idea comes into play. It's like an AI conductor stepping up to lead the orchestra. So instead of being walked into one strategy, this new AI agent dynamically switches between the slow but safe Precopy and the fast but disruptive Postcopy. It's constantly watching the live workload and making the perfect call at the perfect moment to get the best balance of speed, stability, and, most importantly, energy savings.
So how in the world does this AI brain actually work? Well, the whole approach is surprisingly elegant. You can think of it as a two-part brain with two specialized AIs working together in perfect sync.
The first part is the map maker. Now, technically, it's a graph neural network, or GNN. Its only job is to see everything. It scans all the virtual machines, all the physical servers, it figures out how they're all connected and what they're doing, and it creates this incredibly detailed, real-time map of the entire dataset.
And then comes the second part, the smart pilot. This is a reinforcement learning agent. This pilot takes that live map and, using that complete picture, makes a split-second decision. Do we stick with Precopy, or is it time to switch to Postcopy? And here's the really cool part. Every time it makes a good call that saves time or energy, it gets a reward. So it's constantly learning from experience, getting smarter and more efficient with every single migration it does. Okay, so all of this sounds amazing in theory, right? But does this AI conductor actually deliver in the real world? Well, the results really do speak for themselves. Let's look at the numbers.
First up, raw speed. On average, the old methods took about 52 seconds to finish a migration. The new AI method, it gets it done in just 45.5 seconds. That's a 12.5% improvement, which is a huge time saver in a world that literally runs on milliseconds.
But speed is only half the battle. What about the actual impact on users? Well, look at this. Service downtime is slashed by 23%, dropping from 20 seconds to just over 15. That means a much smoother experience and a massive win for reliability.
And this right here, this shows you the secret to its incredible efficiency. The AI is so smart that it manages to spend over 91% of its energy in that super efficient, non-disruptive pre-copy phase. The more demanding post-copy phase, it uses barely 4% of the total energy. I mean, that is just a masterclass in optimization.
So let's put it all together. When you compare this new AI framework to the previous leading methods, the conclusion is just crystal clear. It isn't just a little bit better on one thing. It wins across the board. It's faster, it's more reliable, and it's more energy efficient. It is a total clean sweep.
Now, these results are obviously impressive, but what does it all mean for the big picture? This isn't just some technical tweak. It's a really meaningful step towards building a smarter and much greener cloud for all of us. I mean, achieving 91.4% energy efficiency in a process this complex is just a remarkable achievement. It proves that by using smart, adaptive AI, we can seriously cut down on the environmental cost of our digital world without sacrificing performance. We can have our cloud and make it greener, too.
And that just leaves us with a really fascinating question for the future. We've just seen AI optimize the invisible machinery that runs the internet. So what other complex, hidden systems that run our world, from power grids to supply chains, are just waiting for their own AI conductor to make them smarter, faster, and more sustainable? The potential is just immense.